After discussing about different volume types and their benefits for containerized applications deployed in a Kubernetes cluster, let's look at an example on how to consume a volume in containers inside a pod. In this video, we demonstrate how a host path volume is shared by two containers inside a pod. We then show how the shared volume outlives the pod. Let's begin by creating a new directory on the Minikube VM. We start a shell into the host with Minikube SSH. There we create a new directory. Make dir pod volume. We change into the newly created directory and then we display the full path. cd pod volume pwd, which displays home docker pod volume. We need to remember this to reference it in the pod configuration file when defining the host path volume type. Now let's exit the Minikube VM, returning to our terminal. Exit. Now let's review the shared pod YAML configuration file. So cat share pod YAML. We name the pod share pod. We assign it a label, app share pod. We define a volume of a type host path. And as you can see, we reference the home docker pod volume, the directory created on the Minikube VM. Then we have two containers. The first container, an Nginx image, which mounts the volume under user share Nginx HTML. And then a second container, a Debian image, which mounts the same shared volume locally, and then it executes a command by modifying the index.html file. And as a result, the Nginx web server will no longer serve your typical Welcome to Nginx page. Now let's create the pod with kubectl create -f share pod YAML. And verify that the pod and both containers are running. kubectl get pods. And we see the share pod has two containers ready out of two, and it's running. Let's now expose the pod through a node port type service. kubectl expose pod share pod type node port port 80. Now let's list the services and endpoints. kubectl get services endpoints. So we see the share pod service is of a type node port. The high port has been defined as 30522. And then we see the share pod endpoint. And we see that it has the pod's IP. Now let's view the Nginx page in our browser. So Minikube service share pod and it displays the index page of the Nginx web server in a new tab in our browser. And as you can see, it no longer displays the typical Welcome to Nginx web page. It displays Introduction to Kubernetes, because the Debian container reset our index HTML file. Now let's see what happens if we terminate the pod. First we close the tab, then we're switching back to our terminal, and we issue kubectl delete pod share pod. The pod is being deleted, but we're leaving behind the service and the directory that we defined on the host, the Minikube VM. Let's check pods. kubectl get pods. And we no longer see the share pod running. Let's check services and endpoints. And we see that the service is still running. However, the endpoint, it does not show any more IPs. That is because the pod has been terminated and the pod's IP has been released. Now let's create a new pod named checkpod. And let's look at its configuration. This is a simple pod with a single container, an Nginx container, which will mount the very same volume that we've used before. This container, however, will only read from that volume. It will not make any changes to it. Now we create a new pod. kubectl create -f check pod. Then let's display the pods. kubectl get pods. And we see the check pod is running. And it only shows one container ready out of one. And also let's display services and endpoints. We see the SharePod service, which we created earlier. And now we see that the SharePod endpoint has been populated with the newly created pod's IP. Now we can reuse the old service to expose the pod's Nginx web server. Can issue Minikube service, and I call again upon SharePod service. And again, it opens up the Introduction to Kubernetes site. And this shows us that, as expected, the changes initially made to the hostPath directory have outlived the life of the pod.